is your last quiz review video of the semester, which is exciting. This quiz is on rational functions. As always, I'm going to go through this whole practice quiz top to bottom. You do not have to watch the whole video. Use this as a resource. Skip around to just the questions you need to. And make sure you pause and rewind as you need. Right? I'm going to go pretty quick, but there's no reason you can't pause the video to check your understanding or go back and rewatch something you missed. Okay? And then this first problem, it says determine the features of the following function, right? And then this is important to note. We can write none if anything doesn't exist. So especially when we're talking about asymptotes, not every graph has an asymptote for like both horizontal and vertical. So none is a fair answer. That being said, don't just write none because you're not sure how to do it or because you like saying none. Have a reason to back it up. Okay? So horizontal asymptote is the last thing we did. By the way, this first set of problems is exactly like your last Delta Math assignment. So if you did that and felt confident, you'll probably cruise through this and won't need to watch this whole video. So horizontal asymptote has to do with the relationship between the biggest exponents on the top and bottom, right? In this case, we see that the degree of the bottom, I'll say denominator because it sounds more scholarly, the degree of the denominator is bigger than the degree of the numerator. And then what that means, right? And by the way, right, the degree of the numerator is 1. What that means is that the bottom is like a parabola. So if you imagine what a parabola looks like, it increases very quickly. It's very steep, right? Whereas this line is less steep. And this parabola gets steeper and steeper as x gets bigger, where the line stays the same, right? So this means that the bottom of the fraction is growing more quickly. And if the bottom of the fraction is growing more quickly, f is getting smaller and smaller as x goes up, right? So by smaller and smaller, I mean closer and closer to 0. So the end of this graph is going to look something like that. And what that means is our horizontal asymptote is the x-axis, y equals 0. Remember, there are 3 different cases to figure out horizontal asymptotes, and I go through all 3 of them in our last video on Delta Math. Okay, vertical asymptote is where we start factoring. I'm going to make sure I rewrite this very carefully because this is actually the second time I'm recording this because I copied the function wrong in my first version and had to start all over. So don't do that. Okay, so remember we factor this now. So I rewrite it, and I'm going to take a 4 out of the top and just get x minus 2. Right, because 4 times x is 4x, 4 times 2 is 8. And on the bottom, I'm going to get x minus 2, and then x plus 1. I would like you, at the end of the year, to be in the point where you can do that in your head for these kind of easier ones without having to write the x. But obviously, if you get stuck, write the x. I'd rather have you solve it than just try to do it in your head and not do it. So we're looking for 2 numbers that multiply to negative 2, add up to negative 1. Those 2 numbers are, of course, negative 2 and 1. Okay. So there's my function, simplified, right? And remember, the reason we're simplifying is because we're looking for any terms that cancel out. So in this case, obviously, x minus 2, that's really just a fancy way of writing down 1, anything over itself. So what's left over is 4 over x plus 1. So this factor, I should say, is related to the asymptote, right? So if a factor is left over in the denominator, it's not part of the domain of the function, it is an asymptote for the function. So we'll say y equals negative 1 is an asymptote because it makes x plus 1 equal to 0, right? So that's my vertical asymptote. And then my whole is related to the term that cancels out. So we want to represent that 2 makes the denominator equal to 0 too in the function as it's really originally written. So we say there's a whole at x equals 2. But notice we want a point, x comma y. So I have to get a y to go with my x. And well, the way that I do that is I say f of 2, well that's equal to, and I'm just going to use this guy, the simplified version, because it'll make my life easier. That's equal to 4 over 2 plus 1, which is equal to 4/3. So that's my y. So my whole point would be, I'd use x equals 2 and y equals 4/3. That would be my point, 2 comma 4/3. Okay. So if you graph this on paper, you would make, the graph would pass through this point, and then you'd make a little open circle there to represent that that point's actually not included. Okay, so next one, x-intercept and then y-intercept. And these are ones that you've known how to do forever, right? So x-intercept is where y is equal to 0 on the graph. We want to know the x, and here is where x is equal to 0 is the y-intercept, so we want to know the y. Okay. And I can use the simplified function to make my life easier. So I have 0 for my x-intercept equals 4 times x plus 1. And this should be a weird thing, right? This should kind of make you feel a little bit uneasy. So what I might do, I notice I have an x in the denominator. What I might do is I multiply by x plus 1 on both sides, because I'm thinking I gotta get x plus 1 out of the bottom, right? But notice what I get is just 0 equals 4, right? So this cancels, 4 is left over, and then 0 times blah 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 is still 0, right? So if you're thinking that this means something in particular, you're right. This tells me that the answer here is none. So for this guy, if you graphed it, it would never touch the x-axis. And that makes sense, right? Because it's got an asymptote at the x-axis. So an asymptote is a line that it never touches. So it makes sense that it would have no x-intercepts, right? And that's because there is no x that I can plug in that's going to make my right-hand side equal to 0. Okay? So that was the hardest part of this particular problem, I think. So make sure you understand that. Now's a great time to pause. We'll do the y-intercept here in a second, and then we'll move on. Y-intercept's a little bit easier, though. Okay, so y-intercept is where x equals 0. So we're going to say f of 0. And again, I'm going to use this simplified version. So f of 0 equals 4 over 0 plus 1. And this one's easy, right? 0 plus 1 is 1. So that's just equal to 4 over 1, which is 4. So my y-intercept's 4. Like I said, that one's pretty easy. Okay, so you should have had an easier time on all of these as long as you did the last delta math. If you did not do the last delta math and you're feeling a little lost as you're watching this, that is why. So it'd be a great idea to go back and do that delta math assignment before you jump into the quiz. If you're ready, we're going to move on to the word problem on the next page. So like I did on a recent quiz, also I'm going to give you the graph on Desmos as just like a link so you can open it up and we don't have to worry about making sure you type it in correctly. Okay? So the first thing you want to do is make sure you read it. We got through some of this at least in class, hopefully. So we're running a restaurant and we're trying to keep costs down. And we pay $2,000 in rent each month, and each meal I serve costs $9 in labor and ingredients. Now, notice I don't actually have to do anything with those numbers, so I underline them. But actually my function's already given. So you wouldn't even necessarily need to read all that in this particular case. Oh my gosh. There we go. So zero in these problems anytime you see a function. Notice 2,000 is already included in the function and 9 is already included in the function. And it says your average cost per meal in a given month is modeled by C of x equals blah, 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 where x is the number of meals you serve. That is important, where it tells me what the variables are. Okay? So we're going to go through each one. The first ones are easy, and I put these in there specifically because I don't think necessarily everybody's reading the whole text every time. So this is just like what do the variables represent. So x is number of meals based on what I just annotated, right? So that's why I did that, number of meals. And then c is cost. And we're going to make that even more specific. We're going to say average cost per meal. And if you think about how this function's built, that makes sense, right? So the average is the total. So $2,000 plus $9 per meal over the number of meals, right? So average is always you add up whatever you get and then divide by the total number of things. That's actually what we're doing here, and that gives us a rational function. Okay. So you'll pull up the graph and you'll see something that looks like this, right? And the question, hopefully you got a chance to read it, is this graph occurs in two parts. And what I mean, right, is it has this part in the 1, 2, 3rd quadrant, right? And this part in the 1st quadrant. Okay? So take a second, look at what that graph looks like. I'll pull it up again here in a second, or you can even open the link in another tab, right? So we'll be answering questions about this graph. And the first one is at what x does the horizontal asymptote occur? And here's the graph again. That's x equals 0, right? The horizontal, or that's a typo, that should say the vertical asymptote. At what x does the vertical asymptote occur? So, vertical. I'll change that before it's in front. Okay, so our vertical asymptote occurs at x equals 0. Okay. And then why does this make sense based on the denominator of the function? Well, the denominator is just plain old x. So x equals 0 makes our denominator 0. So that's all I was asking there, not a trick question. Makes the denominator equal to 0. So it's not part of the domain. Okay. The domain of the function as written. So this one's kind of a throwback. This one is like, where does the function live? And we'll answer this one based on the graph. So notice, even if I zoom way out, right? Well, not so far that we can't see. The graph lives everywhere except for x equals 0. So the domain of the function, here's what we want to write an interval. The function lives on -infinity to 0, and then from 0 to infinity. Okay. And we want to do parentheses always with infinity, and then parentheses with 0 because 0 is not included. 0 is the asymptote, right? So it doesn't touch. So we can draw a u in between. Okay, so that's the domain of the function as written. So those are all the x's that I can stick into this function. And then the appropriate real-life domain. So this is like your common sense question, which is probably the most important question, at least will be 10 years from now, is whether you develop common sense or not, right? So the appropriate real-life domain ties back to what do the variables represent? Specifically, what does the x represent, right? And x is the number of meals. So you can make an argument for 0 again, but 0 would be including numbers like 0.5, right? I think the most sense would be from 1 to infinity. And notice I did a pointy bracket this time. So the smallest number of meals that I can sell at my restaurant is 1, right? 1 is included, that's allowed. And then I can sell as many meals. Hopefully I'll sell a whole bunch of meals after that, approaching infinity. Okay. That I think was the hardest question on this page, so maybe pause and reflect Did you follow that or did you not? So ask yourself, can I explain why 1 to infinity bracket is a good real-life domain for this function or not? And if not, rewind a few seconds. Okay, now, last one. What does this mean what's the horizontal asymptote? And I meant to say that this time. And what does this mean in the context of the problem? Okay, so this one's hard to see from the graph necessarily. So we'll use the rule. And remember, the rule has 3 cases. And if you need to look those up while you're doing the quiz or to answer this, that's okay. But in this case, notice the degree of the numerator equals the degree of the denominator. Okay? So we have an x as our biggest exponent and an x as our biggest exponent. What that means, right, is you need to divide the coefficients. So I have a 9x over x. The 2000 really doesn't matter in this case. So I have a 9x over x in my function. My horizontal asymptote is just y equals 9. Okay. I'll give you guys this note. What we did here is, so we divided the coefficients. So there's my horizontal asymptote at y equals 9. And then we'll answer the second question. What does this mean in the context of the problem? The meaning, we could say, so the average cost per meal, so remember that's our y, we wrote that down, approaches, so remember the horizontal asymptote is what the graph approaches, so approaches $9 when you sell a lot of meals. So remember, we talked about end behavior, right? That's what a horizontal asymptote is. So if we want to talk about average cost per meal, when I put the graph in front of you, what we're saying, right, is that as this graph approaches like a large number of meals, as the number of meals gets larger and larger, so in other words, as your restaurant is in business longer and longer, right? So move over here towards my face. Our average cost per meal tends to be $9, right? So in the long run, like, we're paying $9 per meal, so we need to be charging at least that to cover all of our costs, right? So that's why that is useful to us, and that's why I'm asking you about it. Okay. As always, feel free to rewind, come back and rewatch this video as you're taking the quiz. I'll post the written solutions as well. You'll see similar but not exactly the same problems on the quiz. Let me know if you're struggling, and we'll see you next week.